Hello everyone, myself Shekhar. I'm from CSE department. Today let us discuss about the topic Introduction to DFA Minimization in the ATC, that is Automation Theory and Compiler Design. In this Introduction to DFA Minimization, DFA minimization crucially concept in automata theory aimed at simplifying the structure of deterministic finite automata by reducing the number of states while preserving the same language. DFA minimization facilitates efficient computation and memory usage in various applications, including software design and natural language processing. Definition of a DFA. A deterministic finite automata or DFA is mathematical model consisting of a finite set of states, input alphabet, transition function, initial state, and set of final states. It accepts or rejects strings of symbols and is widely used in formal language theory and computer science. Now we can see the importance of DFA minimization. Efficiency in computation. Minimizing a DFA reduces the number of states, making it more efficient to process and analyze, easier to understand. Smaller DFAs are easier for humans to comprehend, making it simpler to interpret and work with the system. Optimizes memory usage. Minimized DFAs require less memory allocation, enhancing performance in memory-constrained environments. Now we'll see the steps to minimize a DFA. In the first step, we can see that remove unreachable states. Identify and eliminate states that cannot be reached from the start state. Step 2. Merge equivalent states. Combine states that have the same behavior and transition to single state. Step 3. Update transition function. Modify the transition function to reflect the merged equivalent state. Step 1. That a removable unreachable state, we'll discuss that deeply. Identify unreachable states. Start by identifying states that cannot be reached from the initial state using transition function. Mark unreachable states. Once identified, mark these unreachable states as they are not part of the language recognized by the DFA. Eliminate unreachable states. Finally, eliminate the marked unreachable states from the DFA to simplify and optimize its structure. Step 2. Merge equivalent states. Merge equivalence. Merging states with equivalent behaviors to simplify transition functions. Transition simplification. Reducing complexity by combining states with identical transitions. Final state unification. Unifying equivalent final states for a more efficient DFA representation. Step 3. Update transition function. Check transition table. Review the transition table to identify redundant or unnecessary transitions. Combine equivalent transitions. Consolidate equivalent transitions into a single transition to simplify the transition functions. Verify function integrity. Ensure that the updated transition functions maintains the functionality of the original DFA. Step 4. Update final states. Definitions. Final states represent the accepting state of the DFA. Number of final states, minimizing to the fewest final states optimizes the DFA. Impact on language recognition. Changes in final states directly affect the recognized language. Let us see the example. In minimization of DFA, the diagram consists of five states: Q0, Q1, Q2, Q3, and Q4. Q0 is the initial state and Q4 is the final state. We can see the transition table: Q0, Q1, Q2, Q3, and Q4. In this, we can see the transition, and we have to generate a table. It consists of at the horizontally it consists of it starts from Q0, Q1, Q2, Q3, and vertically it starts from Q1 to Q4, Q1, Q2, Q3, Q4. First, we should mark the boxes in which the final state which consists. So Q0, Q4, Q1, Q4, Q2, Q4, Q3, Q4. These four nodes are consists of a final states, so it can be marked. In the transition, we can see that Q0, Q3, and Q1, Q3, and Q2, Q3 are marked. In the second attempt, Q3, Q1, Q1, Q4, Q2 are marked. Then in the third attempt, Q0, Q2 is not marked. So the final minimized DFA is given in the figure. The conclusion and key takeaways. After understanding the process of DFA minimization, it becomes clear that removing redundant states and optimizing transitions are crucial. By emerging equivalent states and updating transition functions, the DFA becomes more efficient. It's important to update final states to ensure accuracy. Overall, DFA minimization is an essential concept for optimizing finite automata. Thank you guys.